So let's think of the scenario, Coyote with the boulder on top of the cliff wanting to squish poor little Roadrunner. And as we know, Roadrunner never gets hurt and Coyote always has it backlash at him and he ends up getting hurt himself. Now, first of all, you could say, okay, he has gravitational potential energy. Now notice here, instead of writing all of this word, I'm actually just going to put here, GPE, gravitational potential energy. Makes it an awful lot easier when you're actually writing this stuff. He's got gravitational potential energy in that boulder. He's going to turn it into energy that's moving on the way down. So that's going to be motion energy or kinetic energy with motion in it. Okay? As it's going down, it's going to be losing gravitational potential energy and gaining or speeding up because of its motion kinetic energy. So we've got here already a little picture. We start here with gravitational potential energy and we're going into kinetic energy of motion as it falls down. Now that's a basic what we call energy chain. We've got one thing and it's turning into another. But that's actually not the entire picture. How did he actually get gravitational potential energy into that? He had to push it up the hill, didn't he? To do that, he had to put an awful lot of work into pushing that boulder up. Where did the energy come from to push that boulder up the hill? Well, you know, if you push something, you need energy that comes from your food. So, in order to actually push that thing up the hill, he had to burn his chemical energy from his brekkie, and he had to push it up the hill, so he had to give it kinetic energy, motion energy, to push it up the hill, to give it potential energy, to then drop it on Roadrunner's head. So it actually starts a lot earlier. He had the chemical potential energy of his food, turned it into kinetic energy of motion to push it up the hill, which then gave it gravitational potential energy to drop on Roadrunner's head. Then he dropped it off the top of the hill, which gave it kinetic energy motion again. So now we're getting into a bit more of an energy chain. Notice that the energy has gone from one type to another type to another type to another type. Every time it changes type. We call that transforming energy. If it changes type, we're transforming it into something new or different. We haven't lost the energy, it's just taken on a different form. Now, sometimes you'll actually have energy which is the same type, just moving between objects. And I'm going to give you the last part of the scenario here. If it does go down the hill, and if it did actually hit poor Roadrunner in the end, what would happen to Roadrunner? Well, we all know he'd end up a very flat Roadrunner. Okay? He'd be squished. Now, to squish something, you actually have to move the atoms in that thing. In order to squish them, you have to change their position in that object. So if you get squished, it's because your atoms are actually moved and rearranged and squished together. You have changed shape. And when you change shape, you move atoms to do that, which means you're actually, if you're moving something, what type of energy have you got to change shape? It's kinetic energy. Kinetic energy is the energy of rearranging atoms to change shape. It's just on a different level than what you're used to seeing. We can't actually see the atom go from here to here, but we can certainly see the squished object in the end. So that kinetic energy up here of motion energy, if it actually did hit Roadrunner, and it would hit the ground as well, that ground and the Roadrunner would change shape. And to change shape, you're actually moving the atoms, which means you've still got kinetic energy. It's just the kinetic energy of changing shape rather than moving something from one place to another. When we have this kinetic energy going to another form of kinetic energy, we don't call that transforming, we call that transferring, because you haven't changed the type of energy. All you've done is change what object it's within. We've gone from the boulder into changing the shape of poor little Roadrunner. Okay? That is what we call an energy chain. All of the different types of energy, where they start, what they turn into, they're going from this energy to that energy. Notice that I have arrows between them. And the last little thing that I'll add is not all of those energies go fully from one object to another. As you've got them falling, you've got this gravitational potential energy, that boulder falling through the air. Does all of that energy go into Roadrunner when it hits? Or does some of it go somewhere else? Does all of it go into rearranging him and squishing him? Or do you see energy in other forms in that situation as well? Think about it. If something's flying through the air, can you feel the friction of the air hitting you? If there's air hitting you as it's going through, racing through the air, you actually have heat being transferred into the air. You're actually losing some of your energy in the form of heat. And if you hear it whistling as it falls down, you've actually got some of that kinetic energy being lost as sound. And when the boulder hits Roadrunner or the ground, you're going to hear a great big as they squish, which means not all of that energy has actually been transferred into rearranging the atoms. Some of it got transferred into the sound of the squish. So we can actually make this picture a little bit more detailed. Because here we've got some energy being transformed into heat because of the friction as it flies through the air, and sound. They're the main ones that waste energy everywhere around us. As it's falling, not all of that energy is turning into kinetic energy of falling. Some of it is being wasted heating up the air as that boulder hits all of the little air particles around it. It actually heats them up and helps them to vibrate more. So it's heating up the air, and you'll hear it. So there's sound energy being released there. So not all of that energy goes into kinetic energy. Some of it is lost. And when it's lost, notice how I put an arrow out to the side. That's because, is it actually achieving my ultimate objective of falling and squishing the Roadrunner? How does heat and sound help me squish him better? No. I can't actually use that heat and sound to squish Roadrunner, therefore it's lost to me, and therefore I put it as a little arrow going out of my energy chain. As he was pumping his muscles to push that boulder up the hill, did all of his energy go into pushing that boulder, or did some of it get lost as heat because he was sweating? And did some of it get lost as sound because you would have heard the crunching of that boulder as it pushed across the ground? And some of it would have been lost in many other little ways. You actually lose every time you transfer or transform energy. Not all of it will be transferred or transformed. Some of it will be transformed into types of energy you don't want it to. And we call them lost or wasted types of energy. So you've done an awful lot of learning now with not only about the different types of energy, but we've now gone through how to put that into a picture. Now the only way to get better at this is to practice. And I like practicing on things that we actually really get or we've tried out before. So we're going to practice with examples of Coyote and Roadrunner, and we're going to practice with examples from our investigations in the classroom and see if we can put them into pictures to really depict what's happening, what type of energy we're using, what type of energy we're making and where we're losing energy and it's not doing what we actually want it to do. You're going to be practicing doing all of these conceptualizations so that you can actually then figure out how to make your machines better. That's the ultimate goal here.